and welcome to Ashnik's Hangout on Postgres 10. Postgres 10, that's really a landmark journey, I would say. Postgres had its first community release in 1997 and it has completed now 20 years and 10 major releases. It has been a fantastic journey for open source technology like Postgres. And we have the most suitable person to talk about Postgres 10 release, and which is none other than Samir Kumar, who has been very active in Postgres community and has been helping our customers across Southeast Asia in various terms, in terms of consulting, architecting, helping them in their backup strategies, implementation of Postgres related high availability and DR setups and whatnot. Can you tell me what's the blockbuster feature of Postgres 10?
I think that's a very difficult question when you talk about PostgreSQL 10. There are a lot of great features coming up in this release that users can look forward to. And now a lot of these on their own could have made it to the key highlight of any release. But all of them have to compete against each other in PostgreSQL version 10 to get the spotlight. If you really force me to choose, I would say there are now more parallel and parallel queries which would be possible in the version 10. There is now upcoming in-code logical replication feature in version 10. There is going to be declarative partitioning to ease the way partitioning is done today. And then there is quorum-based synchronous replication. I would say these four are my picks.
You mentioned parallel querying, right? So it has been there since 9.6, if I'm not wrong. And so what's new that is happening in this release, specifically related to parallel querying?
People will have access to more parallel plans. People will be able to see more parallelism in action in their queries, and particularly around index scans and joins which are depending on index scans will be parallelized. So while you're right that parallelism was introduced in 9.6, but that was just the basic parallel query. And now based upon that, using that as a building block, a more enhanced parallel query feature will be added in version 10.
Okay, and same goes with logical replication. I believe it has been there since 9.4, and we have. I remember we have some customers who are using logical replication today. So what's different now?
Until 9.4, there was logical decoding, and then you can build logical replication on top of this feature. So logical decoding allows you to have all these queries or changes logged into your write-ahead log file in a way which can be decoded and reapplied on a different database. But still, you have to use a different vendor or a different tool. It could be open source or could be provided by a vendor like Enterprise DB's EDB replication server, which allows you to perform this replication from these WAL files, receive these WAL files, decode them, and apply it on a PostgreSQL database. But now, that feature will be available in code.
Oh, okay.
That means you will be able to set up logical replication with the same ease and with the same simplicity that you can do with streaming replication. And you don't need a third-party tool for that. While tools like Enterprise DB's EDB replication server and other tools of industry would still have their own value add, but the fact that logical replication is now available in core itself. So two PostgreSQL databases.
The Postgres engine itself.
Yes. So all you need to have a logical replication setup is two PostgreSQL databases.
So you don't need to install any other separate tool. It just once Postgres is installed, it's part of that binding.
Yes.
Okay, that's exciting. And you also mentioned about declarative partitioning. Tell us more about how is it going to help? Is it going to make the partitioning a lot easier, faster?
It is going to make partitioning intuitive and beautiful. So users will have a much cleaner code when they look at their partitioning code. Instead of having to create child tables and create triggers, check constraints and all those things. Now they can create partitions just by using partition attribute in the create table or alter table statements, which is very similar to how partitioning is offered by a lot of proprietary databases. So while partitioning was available in PostgreSQL, users always complained about how painful the whole process is. And while the process was painful, the outcome also could have its own flaws, and there could have been errors. And I have seen situations where users created overlapping partitions. So while new feature in version 10, it makes it more intuitive for users to read the code and understand how the data has been partitioned. It also makes it more beautiful, more maintainable, and also less prone to errors, because all the overlaps will be checked by the engine when you submit a create table statement with partitions. So that is a great thing, and I really look forward to that, and I look forward to trying it out for a few customers who are looking for partitioning solutions.
I remember beauty lies in the eye of the beholder, and you are the first consultant, I would say, who's seeing the beauty in the logical or declarative partitioning, I would say. That's really good, good to see. And you also mentioned, I think the fourth feature that you mentioned was quorum-based synchronous replication, correct? So how does that help?
Till version 9.5, you could only create one synchronous standby. That means you can still specify a list of standbys, but only one of them will be synchronously following the master.
Okay.
Now, come version 10, you can not just have multiple standbys following the master, which was a feature introduced in version 9.6, but now you can also say that, let's say I have 5 standbys. Out of this, any three standbys could follow the master synchronously. Now, the advantage of that is now Postgres doesn't really have to go around check each and every standby node whether it has committed or not in a priority list, but it can just wait for any of the 3 standbys to acknowledge that, hey, we have got the commit, we have received the vol file, and that makes your replication process a little more efficient, because now the master doesn't have to wait for all commits or doesn't have to wait for all 3 servers in a priority list. And this could be especially very useful when you have heavy OLTP load and you are more concerned about the durability of the data and less concerned about which server receives the commit first.
Okay, so that means for those customers like banking or insurance related industries, this is going to be really very useful feature.
Oh yes, this makes PostgreSQL very reliable and durable at the same time, without it does not compromise anything on the performance side as well.
Right. And how about the security part of it? And you didn't mention any feature in this blockbuster really. But I'm sure there must be something on security.
Oh well, yeah, there are a lot of security enhancements as well. And if I had a 5th choice to make to pick, I would say it is scram authentication. A lot of Postgres administrators, and especially people who are very stringent on their on securing their environment, have always complained about using MD5 authentication, where passwords are MD5 hash and they are stored in the database. And that also means that the user passwords are exposed in the backup scripts, or they can be queried from some of the system views like pgauth. Now, all that is going to be taken away. All that is going to be taken away in version 10, because it's going to use scram mechanism for hashing the passwords and for storing the passwords internally. That means that passwords are more secure now, and you don't really compromise on the security aspect by taking a backup, which was the case earlier. And I remember having spoken to a large bank in Indonesia who was very concerned about this particular aspect of Postgres authentication. But that is now going to be taken care of. Also, there is role-level security, which now allows you to define multiple row-level policies or access policies on the table data. And you can also define whether all these policies are to be combined together. For example, you can define a policy which allows users to query the data or see the rows based upon their user ID. Another could be based upon their group ID. And you can say that the user should be able to access the data if he can directly access it or his group can access it. So there is an OR between these two policies. Or you can say that user should be able to access only when the user has access and his group also has access. So there is an AND between these two queries. So these two policies. So that is definitely a good facility now available to even further secure your data, especially when people are doing row-level security or where people are storing data from multiple users and they're concerned about exposing data to other users. Then there is also new roles which are introduced in version 10, which allows monitoring users to only have access to monitoring views or monitoring functions. They will not be able to access other tables or user tables. So previously, to give monitoring permissions, users had to, or DBAs had to grant the super user access or more towards access. Now that has been taken off. So I don't have to be a super user to view the monitoring data.
That's really useful. I mean, recently we had the case where one of the ISV was working on the database side and they wanted access to super user access basically to do something, and we had to go back to the customer to specially grant them access.
They specifically wanted to have access on some of the table statistics to find out how frequently the table is being used and how many index scans are happening. That actually was useful for them to do some further tuning in their SQL schema. But sharing, the super user access with them is a very very scary thing for customers. But now they don't need to do that anymore. They can simply give access to these monitoring roles, and that would be enough for these ISV vendors or third party to come and look at the database.
So all these features that you have mentioned till now are making Postgres as a very, very strong RDBMS, and from strong to stronger rather, I would say. But many times we have encountered customers who are choosing Postgres not just as an RDBMS system, but their choice of technology or Postgres is based on the very fact that it has been one of the most innovative, very rich community in terms of innovative features. So what is there in terms of innovation that you say it's the topmost innovative feature?
Cross-column statistics, which is fantastic. It is an awesome feature. It is a game changer for PostgreSQL.
Why do you say so?
Because now you will be able to define that there is a correlation that exists between two fields. Previously, all these cases where there was a correlation between two columns, in those cases, the optimizer or the query processor used to have a lot of trouble finding the right plan, and it often used to choose suboptimal plans. There were ways to achieve it, to push it towards a better plan, and all those ways were basically to introduce some kind of common table expressions to force it, or use some kind of metallization and make it choose a better plan. But that was really quite taxing on DBAs, and you really needed good tuning skills to get that to work for you. And also there was no guarantee that it would work any differently when the statistics or when the data distribution changes slightly. But now in version 10, you will be able to tell Postgres that, hey, actually there's a correlation between, let's say, the country table and the city table. So you can expect that these two columns will be mostly used together in the queries, and you should always also try to look at the data distribution of these two together as a whole. So Having said that, there is something really very different where the ability to define the correlation has been given to the users, where a DBA can say that I see that this has some correlation, or the application, not the DBA, but more often you will see the application developers would be able to define that there is a correlation that exists. That is really fantastic. And then my favorite is foreign data wrappers, which is again an enhancement over the features which had come in version 9.6. And I feel that slowly PostgreSQL community is laying down a foundation to build a rock solid relational database with distributed data capability.
Tell us more about FDW, because I have been hearing this from many customers.
It allows you to access data residing in foreign databases or remote databases. It's kind of a wrapper layer on top of these databases. So basically, you can think of these foreign data wrappers as a connector to a different database, which allows you to expose data lying in these databases as native Postgres tables.
Okay.
So you can create a foreign data wrapper to access data in MongoDB and expose that into a Postgres table. So you can query that Postgres table. Underlying it translates the select query, converts that table definition into a collection definition, translates your select query into a MongoDB query, and gets that data for you.
Okay, so what's new in this release now?
There were great enhancements which have been actually happening ever since this was first introduced.
Okay.
There was filter pushdown, and then that filter pushdown was adopted by Postgres FTW.
Okay.
So, the most popular foreign data wrappers, which are also endorsed by community, are PostgreSQL foreign data wrapper and file foreign data wrapper, and they allow you basically to connect to a different PostgreSQL server and fetch data from there.
Okay.
In 9.6, there was facility added that the filter queries will get pushed down to the PostgreSQL remote PostgreSQL servers. So if you say select star from EMP, where EMP or employee is basically a table lying on a remote server, remote PostgreSQL server, not the whole data will be fetched, but only the data which satisfies your where condition will be fetched from the remote server. And that filter being applied on the remote server means that the index will be utilized better. And if the data is cached, that also will get utilized.
Okay.
Now, in version 10, you will have more operations being pushed down. And two most important ones is aggregates and joins. So joins can now be pushed down to a remote server. So you can have imagine a sharded PostgreSQL cluster where you have a main server, and then there are 10 servers storing sales data for each and every quarter for last 10 quarters. You can fire a select query to do summation of all the sales data, aggregation of all the sales data of the previous quarter or the quarter before that. And then that aggregation would be pushed down to individual nodes, and they will be performed there, and then you will get the data. That means on your front-end server, more users can fire aggregate queries.
Okay.
Similarly, joins can now be pushed down. So if you are doing a join between sales data and maybe some other data which is common across all the data, all the shards, that data can be combined together, and then you can that join can be pushed down to that node. When you combine this with logical replication, where you have, let's say, a master database where all your config tables are being stored, and then you have shards sitting on all these, let's say, 10 nodes,
right?
And your this data, which is config data, is not very huge, maybe 10 GB in size, is also getting replicated to all the 10 servers. So maybe some sales configuration data or some customer information is like a catalog which is stored across all nodes.
Right.
It gets modified on the main server, but gets distributed to all of them by the means of logical replication.
Okay.
And by the means of foreign data wrapper, you manage to create a child table hierarchy where you have child table sitting on different nodes. You can call them shards. And then you can push down all these joint queries happening on, let's say, some sales data and customer data. You can push down the aggregation queries. So this is a really building block towards the future of sharding in PostgreSQL.
Is this something kind of a miniature, the MapReduce kind of functionality, you can say?
Not so sophisticated yet. Not so much sophisticated yet.
Okay.
But yes, of course, you can look forward to something of that sort, or you can program that kind of thing in your stored procedures, where you are able to distribute, or you can use your jobs in a way when you are able to parallelize. You can write your queries in such a way that when the data can be, the queries could be split and parallelized, and then you can get all that in a summary table or something. So yes, of course, you can design something of that sort on top of it, but by its own architecture, it is not so sophisticated.
But I can see, I mean, the way it is going, this is going to play a big role in terms of big data landscape.
Yeah, like I told you that it's the basic building block or a step towards sharding in PostgreSQL itself. And when you combine this with logical replication, you can also try to see how you can replicate the same data, which is configured across all nodes, and how you can push down more and more operations. So a lot will also depend on how you architect your data and how you set up your architecture. But of course, this release of PostgreSQL, and particularly foreign data wrapper features, is a big step towards big data use cases in Postgres.
Right. I remember a case where one of our customers was storing a lot of historical data in a sharded environment, and they wanted to have a skill interface to access that data. And we had suggested a very similar architecture where they can use a Postgres foreign data wrapper to interact with the application, and the backend can fetch the data from the various sharded, horizontally sharded environment.
Yes.
Yeah.
Yes.
How do you see our customers should look forward to this release in terms of, let's say they are on Postgres 9.6 or earlier releases, and they want to, if they come to you and ask, why should we migrate to version 10, or those who are not at all using Postgres?
I would give them three main reasons to look at PostgreSQL or to look at upgrading to PostgreSQL 10 after this release. First one would be performance and scalability.
Okay.
We spoke about parallel query features or multivariate statistics, which is now going to make queries much more efficient. We also spoke about the performance enhancements in FTW because of the push down. There is also enhancement happening which has happened for analytical queries, which are going to be much more faster. There is also a lot of performance enhancement which happened in the way joins are executed. So all this put together, now PostgreSQL is a much better performing database than the previous release. It is going to be much more scalable, and this today I can say confidently not just about the OLTP workload, which has been a very popular use case for PostgreSQL users, but even for data warehouse and OLAP use cases. So if you are building your data warehouses and OLAP, a lot of those use cases today can be covered very well by PostgreSQL.
Do you mean our customers can build data warehouse in Postgres?
Oh yes, of course. A lot of the data warehouse use cases can be easily now covered with PostgreSQL.
That's exciting.
The reason that I would give you is reliability, better reliability. So this reliability is in terms of durability of your data, durability of the transactions you are doing on PostgreSQL, and better security.
Okay.
So with release 10, PostgreSQL is going to be much more secure database. Like we spoke about, a better authentication, better row-level security, and better separation of duties in terms of a separate monitoring role. And we also discussed how the quorum-based synchronous replication is going to make it much more performing when you're doing synchronous replication. So users have now more reasons to move towards synchronous replication earlier some users were a little reluctant because of some performance shortcomings. Now because of these enhancements, users should be able to get benefits of synchronous replication without having to compromise on anything on the performance side. And then you look at connection failover in libpq, which makes it easier for users to connect with two database servers and have a failover mechanism built in the driver itself. Or when you talk about the crash safe indexes, hash indexes, so which is also a better reliability now, adding to the reliability of objects in PostgreSQL. And one very unique feature which has come up now in version 10 is where you can trace the commits. So a client can query the transaction ID when it begins, and then it can go back and query whether the transaction has been committed or not.
Okay.
So let's say there have been some corner cases when application loses connectivity just after the transaction has been committed on the database. So though the database transaction has been committed, but database is not able to inform application before it loses connectivity. In these cases, users don't have to retry immediately, but once the database comes up, instead of retrying, what they can do is they can query whether the transaction was committed or not.
Okay.
So you have much better reliability built into this new engine of PostgreSQL version 10, which you can easily rely on.
Okay.
And you can rely your mission critical applications on this engine, not just your business critical or not just your non-critical applications, but even your mission critical applications can now run on Postgres with much more confidence. And third thing that I would tell you about in terms of my reasons to move to Postgres 10, it would be big data and noSQL use cases. So I spoke about how FTW can make big data possible within a PostgreSQL RAM itself. But also in last few releases, you will have noted there were a lot of noSQL features added, especially around JSONB. We spoke about a lot of them in our past Hangouts. But in this version, there is a full text search feature which has been added on top of JSONB. So yeah, you can actually perform full text searches on the data stored in JSONB. So maybe if you are building customer 360-degree view, or if you are storing log data in these JSONB columns, you can do a full text search, much like any other full text search specialized database that is out there in the market. You can also now use XML table feature in version 10 to flatten an XML file or XML document into a table structure. And this particularly would be very useful for the financial institutions who very commonly use XML format to exchange data between two bodies. And when, let's say, a bank receives an XML message from, let's say, a trader, or it could be an insurance agency, they try to digest that, flatten that out, and put that into a table. They use some kind of ETL code to do that, or they use some kind of Java application to do that. Now, that could be much easily done with an XML table query in Postgres itself. And you can offload some of that task from your application to the database, which is really fantastic. So Postgres is now much more scalable, better performing, more reliable for your mission critical applications, and it can cover more use cases now with the big data and noSQL features being added.
And really looks power packed release, and I believe that everybody has something to gain, be it a developer or a DBA, application programmer, or for businesses for that matter. Those who are looking for innovation or big data, everybody can look forward to this release in September. And thanks a lot for staying tuned to our Hangout video. If you need any more information, or you want us to be part of your digital transformation journey in terms of consulting, architecting your solution, or just want to talk to us, go to our website www.ashnik.com or write us an email at success@ashnik.com.